Welcome to another generative AI demo series where we focus on securing, delivering, and optimizing modern generative AI applications with F5. If you haven't watched my first video on Enterprise Retrieval Augmented Generations or RAG, I encourage you to do so as it provides a foundational understanding of RAG and how it works. In this video, I will demonstrate an autonomous decision-making GenAI chatbot utilizing Agentic RAG. We will explore what Agentic RAG is and why it is crucial in today's AI landscape. Additionally, I will discuss how organizations can leverage GPU as a service or AI factory provider to accelerate their AI strategies. Furthermore, I will explain why F5 plays a key role in securing, delivering, and optimizing Agentic RAG system. Before diving into the details of Agentic RAG, its architectures, and its inner working, I would like to give you a quick demo. I will showcase an intelligent chatbot built specifically for this demo on Agentic RAG, implemented with the LangChain and LangGraph framework. Don't worry if you are unfamiliar with these terms, as I will walk you through them later on. This is just a quick snapshot of the GenAI chatbot demo. I will provide full details and explanations later. This is my Agentic RAG chatbot. In my first demo video, I showcased the mechanics of how a RAG system works and how I incorporate domain-specific information and knowledge into my AI chatbot. For example, I can ask questions about corporate-specific information like, who is the board of directors of Acadia Financial? The board of directors of Acadia Financial is as following: Tony Smart, chairman of the board. If I ask different questions, tell me more about Tony Smart. By the way, in this demo, Acadia Financial is a fictitious sample company that open source language model will never train on. This is an example of RAG, and where RAGs bring value, where it integrates the retrieval of the organization's internal corpus of data with the capabilities of public language model to generate a more accurate and contextual relevant responses. This approach allows organizations to save time and money by eliminating the needs to train or fine-tune their corporate data into the language model. For instance, I have vectorized and stored Acadia Financial's team and board of directors information in a vector database. When I ask questions regarding board of directors, the chatbot retrieves and provides context-aware information specific to Acadia Financial. RAG solves the problem of delivering organizations specific context, typically sourced from an enterprise corpus of data. This approach is great. However, data stored in vector database are static, meaning that whenever updates occur, this data must be embedded to refresh the vector database. This embedding process, which converts chunks of enterprise data into vectors array, consumes resources like GPU. Although it's less resource intensive than fine-tuning or training a model, it still requires time and effort to continuously update the vector database. This is where Agentic RAGs excel. It overcomes the limitations of traditional RAG-powered chatbot, which depends on static vectorized data. Agentic RAGs enhance your chatbot with reasoning capabilities, allowing it to autonomously make decisions using the power of large language model, rather than just retrieving information from static sources. This enables the chatbot to integrate with the other systems, such as user profile management, ERP, and external SaaS platform, creating a more dynamic and intelligent conversational experience. Now, with Agentic RAGs, I can get my AI chatbot to obtain real-time and dynamic data, such as retrieve my profile. These questions trigger the Agentic RAG pipeline and instruct my agent tools to invoke an API call to my internal API gateway to retrieve my profile information. This is where the information is retrieved from the internal user management system. Let's try another different question. How about get my stock holding? This is the information that as well retrieved from the user profile management system as well. And this is all the profile informations. We can confirm with F5 logs for this action. If I refresh this is F5 platform logs. As this API gateway being secured and protected by F5, it's clearly that there are two API calls, get user holding and get user profile being triggered to retrieve this specific information. How can we confirm that this is not a hallucination or data that the LLM made up? Let's double confirm with the backend system. This user management system is protected by Nginx API gateway and monitored and managed by Nginx One. Let's jump on to Nginx One to confirm. This is where the profiles are retrieved from, the first name, the last name, the email, and so on. Where for the user holding, the holdings of F5 Share, Microsoft, and Amazon. As shown, the value in the user management system align with what the Agentic RAG chatbot provides. This confirms the data indeed obtained from an external system and not hallucination. I can also ask a more real-time question, like, what is F5 Inc. current stock price closing for today? This real-time data is obtained through API call from a third-party system, and as it is impractical to vectorize such dynamic information into a static database. This demonstrates the power of combining language model agents and RAG to supercharge your AI chatbot to a new level of functionality. F5 platform facilitates seamless integrations, helping achieve the goal of an autonomous decision-making chatbot that can access and process both static and real-time data. By leveraging these technologies together, we create a more versatile and responsive AI system capable of handling a wide range of queries from historical corporate informations to up-to-the-minute financials data. Now, let's explore what exactly Agentic RAG is and why it is so important and how F5 brings value. I will return to the mechanics behind the demo later. Please bear with me for a moment. What is an Agentic RAG? Agentic RAG is an advanced AI framework that extends traditional retrieval-augmented generation system by integrating enhanced decision-making capabilities. Unlike standard RAG models, which focus primarily on retrieving context, Agentic RAG incorporate reasoning and autonomy, enabling the AI system to make decisions and take actions based on retrieved data to achieve predefined goals. By combining RAGs with agent-based tools, it creates a more dynamic and intelligent system. In these demonstrations, LangGraph, a library within the LangChain's ecosystem, is leveraged. This AI chatbot applies multi-step reasoning using large language model and trigger external functions or API based on natural language input to accomplish specific tasks. These tools can initiate API queries via Google search, interpret API documentations like Swagger or Open API specifications, and interact with third-party SaaS systems to provide more dynamic and structured outputs. This is how the Agentic RAG pipeline looks like for this demo. I had built 5 agents for this demo. The router agents who is responsible to reason and decide who is the next agent to complete the task. The identity agents responsible to talk to Nginx API gateway to retrieve user information stored on OpenShift container platform. It leveraged LLM with provided Open API spec to understand API endpoint to invoke. Outreach agent who is responsible to decide which API to call based on user question. It called Google API search for latest updated data or talk to the Nginx API gateway for the outbound to retrieve third-party Morningstar API for stock market mover data. Internal agent, who is responsible to retrieve internal document related to Acadia Financial's team information from vector database. And research agent, who is responsible to retrieve internal research document such as F5 financial statement from vector database. Each agent is tasked with reasoning and decision making for a specific task. For example, the router agent plays a critical role in determining which agent should handle the next stage of a task. The router agent is provided with reasoning and specific instructions prompt, enabling it to understand user queries and decide which agent is best suited to continue processing them. For example, the identity agent is responsible for answering user queries related to identity, such as user profiles, stock holdings, account balances, watch lists, and more. This agent is supported by a large language model and is fed with an open API specification, which allowed the agent to determine the appropriate API endpoint to call based on the user questions. The agent then uses a tools to invoke the required API via the F5 Nginx API gateway, hosted on an OCP platform. The raw response is sent back to the language model, which format and present it in a natural language to the user. This structure enables the creation of comprehensive agent loops, which each agent collaborates seamlessly to accomplish specific tasks. Now that you have at least a high-level understanding of Agentic RAGs, you might wonder how F5 is relevant and what role it plays in this system. Let me walk you through how F5 secure, deliver, and optimize your generative AI application using a few key use cases that I will demonstrate later. Before diving into the key benefit and use cases, let's explore the overall architecture for this demonstration. Here is the reference architectures for the Agentic RAGs demo, which I have divided into 3 distinct areas. Each site, which is distributed across multiple locations closer to the user. In this demo, the edge sites are located in Singapore and Australia and span across edge and public cloud. Enterprise data centers represented as DC1 and DC2. AI Factory or SaaS AI providers, including hosted services like NVIDIA Inference Microservices, OpenAI, Mistral, and so on. At the edge site, I have a bare metal F5 app stack located in Singapore and another app stack running on Google Cloud Platform. As depicted in the topology, due to the limited availability and high cost of GPU resources in public clouds, I have configured the system to use GPU as a service hosted in the AI Factory. For demo purposes, I'm using a bare metal AppStack server equipped with local on-box GPU and local LLM as an AI Factory. These AI Factory services are exposed via an API. All of this is made ridiculously simple and efficient through F5 Distributed Cloud Platform. For the enterprise data center, I have 2 sites. I have DC1 and DC2, each containing typical enterprise components. In this setup, there is a user profile system protected by an Nginx API gateway hosted on the OpenShift container platform. The Nginx API gateway is managed through F5 Nginx One, which provides access to the enterprise-grade component for delivering, scaling, and securing apps and API. The reasoning power of the LLM trigger an agent to call an API endpoint via the Nginx API gateway. Additionally, the Nginx API gateway monitors and secures external API connections, such as a third-party SaaS provider like Morningstar, which provide real-time stock market data. Within the enterprise, documents like PDF are uploaded to on-prem S3 compatible storage. In this demo, I'm using MinIO. As part of the RAG pipeline, this data is vectorized and stored in the vector database. Enterprise can choose to perform the vectorizations and embedding process on premises using their own GPU, or they can leverage GPU as a service from the AI factory. The vector database in DC1 is replicated across to DC2 via the F5 encrypted mesh fabric. These fabrics ensure secure and seamless connectivity between all those sites, from edge, cloud, AI factory, DC1 and DC2, spanning layer 3 through layer 7 of the network. F5 SaaS console provides a centralized single pane of glass solutions for the configurations, management, and monitoring of all F5 components. This enhances operational efficiency and significantly reduces the complexity of managing a highly distributed environment. Consistent security, routing, and application delivery policies can be enforced and deployed across all sites. How's F5 secure, deliver, and optimize GenAI application? On security, F5 helps organizations protect their assets by securing GenAI applications and API. Since GenAI apps are a form of modern applications, they require similar web application and API protections. Additionally, API are crucial for GenAI, serving as the foundational communications link between all AI components. F5 helps organizations ensure compliance by enabling them to maintain data within the organizations without requiring data to be transferred to external AI factories or SaaS AI cloud. F5 encrypted mesh fabric ensure that communication between all AI components is securely encrypted. On delivery, F5 platforms enhances business continuity by addressing the digital resilience of GenAI application. As organizations mature in their use of GenAI, these apps are becoming mission-critical components of business operations. Vector database, which store organizations' corpus data, are a crucial component and a prime target for adversaries. Therefore, ensuring the security and availability of vector database is critical. F5 enhances user experience by prioritizing traffic delivery based on user location. On optimizations, F5 helps organizations optimize their GenAI operations in several ways. It reduces operational costs by delivering traffic to appropriate locations where GPUs are closer to users. It also increases operational efficiency by seamlessly connecting all AI components together. By leveraging F5's comprehensive suite of solutions, organizations can ensure that their GenAI applications are secure, efficiently delivered, and optimized for both performance and cost effectiveness. To showcase F5 comprehensive GenAI solution, I had prepared 3 distinct demonstrations that highlights F5 capabilities in securing, delivering, and optimizing GenAI application. For security, I will showcase web application and API protections, where you can see how F5 advanced web solutions safeguard your GenAI applications against evolving threats. For advanced API protections, you will witness the robust security measure that protects the critical API powering your GenAI system. And for encrypted mesh fabric, you will experience F5's state-of-the-art encrypted mesh network, ensuring data integrity across all AI components. For delivery and optimizations, I will focus on GenAI and vector database resiliency. You will learn how F5 maintains high availability and fault tolerance for your mission-critical GenAI applications and vector database. I will also show the intelligent traffic routings, where you will see our smart traffic management in action, directing users to the most appropriate GenAI workload based on their locations or profile for optimum performance. On the final demo, I will offer a unique glimpse into the Agentic RAG in action. I will enable agent message in the chatbot to provide visibility into the pipeline and behavior of an Agentic RAG system. I encourage you to look out for those videos and watch each of those videos to gain a comprehensive understanding of Agentic RAGs and to see firsthand on how F5 can be your trusted partners and provider in your generative AI journey. These demonstrations will illustrate why F5 is uniquely positioned to support and secure your GenAI initiative at every stage. Thank you for your time and hope you enjoy this video. Please feel free to reach out if you need any further information or deep dive discussion. Thank you.